I will tell you a little bit about this buzzword FAIR, and I just borrowed 2 slides of Kurt. He sent me his presentation before, and I was happy I don't have to do this stuff by my own. A lot of people mentioned it already today. There is need for high quality data. Only if you have good data quality, you avoid this garbage in, garbage out issue, and you can bring data together, you can share data, and you are getting interoperable. So we agree that's the goal. And even our politics, they make this very broad and impressive statements. So they say, open scientific research data should be easily discoverable, accessible, intelligible, usable, and wherever possible, interoperable to specific quality standards. This said all the science ministers in 2013. And it then has some effects. Somewhere in the Netherlands, in Leiden, there was the Lawrence workshop. People from Elixir, Maurice Schwartz from PBMR, Netherlands, they sent together and they invented this FAIR stuff we are hearing in all the presentation. Mark wrote 2016 his paper. I would like to have written this paper. It has massive citations since then. The European Open Science Cloud was funded. It started 2015, and now it's even the European Open Science Associations active. And not history, but future. In autumn also, we heard in Prague that there will be the big EC events. There will be the tripartite event, where I wrote down who this is. The Commission, the Association, and all the member states of the European Open Cloud Steering Committee meet. So there's a lot of politics. There's a lot of talking. But I have the impression it's like the climate problem or the climate change. The politicians making big statements, the talking is growing, and the reality looks different. Will we meet the 1.5 degree limit? Will 2022 be the maximum of carbon emissions? I think we see here some parallel developments. On the one side, we agree on the goal. It's good to be interoperable and to be fair and to fulfill all this stuff. But the reality check, if we even look at our work, it's a little bit different, because it takes a lot of effort to make high quality data. It takes a lot of effort to describe all this metadata thing. And how should we convince the data alligator, the nice guy on the left side here, to do all this stuff today, if it will only pay off in 5 years or in 10 years? So why should I put a lot of energy and effort in doing good data quality? I know what's in. I can make the stuff. So and if Heather needs the stuff in 5 years, I don't care. So it's a little bit the same as in the climate. And as it will only pay up in the future, we need to think how we can push people making the things. And there are more or less 2 pillars to push people into doing fair data and good data quality. There's on the one hand the recommendation and regulations. As I told you, political things. Research funder says you only get the money if you put the data management plan in and write 7 times FAIR in each work package. The journal says we publish only a paper if you upload your data. That's a good thing. And scientific communities can push people in doing the things. But there is also not the stick, there's also a carrot. Yeah? So we have the carrot on the right side, the stick on the left side. We can give researchers and people support, and we can give them tools in the hand. Yeah? So they can save some resources. Resources are time and money. Yeah? They can work better together in a team. Yeah? They can get more visibility. Yeah? And they maybe get an early payoff, not in 5 or 10 years if they have some good metadata. And with this tool stuff, we step in. And we are looking what are open source tools in the field to support people to do data management analysis, to do sample management. Are there any open source tools to build up in data repositories? And we found such open source tools. But they have some disadvantages also. As they are open source, you have to pay with your effort to get them running. And it's sometimes not easy to install them, and sometimes not easy to set them up. And they are also missing some of this classical interoperability and parts and provenance support. And we put this in and then we thought how we can put this to the open source tool in addition. And this is now the concept for the FAIR toolbox, which has some history in the so-called PIP box. This was initially the basic infrastructure building box developed in the P3 Africa project. Some of the collaborators and friends are in this room. And you see here, we built really a box for doing for supporting biobanks in Africa and doing sample management and bioinformatics. We built this in the P3 Africa project with an technology called LiveRay and React, some old things. And then we took this experience from there to upgrade it and to base it on this architecture we had in P3 Africa. And it's similar than Jim explained. We have a base environment, and on this we have different apps which are dockerized. And dockerized means somebody has done the work already for you, for installation, for configuration, for bringing things running, and you just have to put your Docker container and say start, and in an ideal world your software tools then run. And around of this we built an app store to select such solutions. And the FAIR toolbox, which we developed in HEAP, then added to such apps for data management two things, the so-called FAIR data point and the Provenance Access Point. And what the FAIR data point and the Provenance Access Point does, I will explain in the next slides. The FAIR data point, it gives a resource level description what's in a catalog. So it's like the Dublin core for books, and resource description what's in a catalog. It tells you who is the contact person, what license you have to use, what is the access procedure, and so on. So it does this in an first in a standardized way. You know what fields to fill out, and more important, it's in a machine-readable way. Machines can come and get this information just by reading the linked data fields. And for the FAIR data point, we have taken an existing solution, which already is here as a Docker container, and we built this together with an app. The next is the Provenance Access Point. That's something which was developed within HEAP, based on an ISO standard which defines a format to describe provenance information for biological specimen and data. And it gives, say, the CV or the history of some data item or some specimen. We also heard today from Kurt, it's important to know about the quality. It's important to know about the pre-analytics of a sample. And this provenance standard gives us a data format and way to describe this. It's working like this. You have an entity, say a sample, and this entity is transformed by an activity. Activity can be sample acquisition, the sample transport, and aliquotation, and sample analysis. Yeah? And so you have a chain where one activity goes to the other activity, yeah? And this is always done by an agent. And in our application field, it would look like this. Yeah? So everything gets then a unique ID, and on the right side, here in this example, you see how this would be encoded in the so-called Prof.O language. And then we take an existing solution, like Open Specimen, which is an open source solution for sample management, and we put a FAIR data point and then Provenance Access Point together with this. Huh? We compile this, and this is then an app which can be installed in our App Store. And GN in the middle, that's the Jupyter Notebook we already learned about in HOPsWorks. And not only one app, but a series of apps can then work together. You see, you have Open Specimen to manage your samples. You have phenotypes to record phenotypical information about patients. You have Molgenis as an open source app to organize omics data, and all of them provide a FAIR data point, and then is a master FAIR data point who can machine readable read the others. We and the main developer is here in the front, Patrick, he has built up a nice demo. If you have some time today in the evening or in the next days, go to this site, explore a little bit how such a FAIR data point works, how provenance access points can work. Yeah? And in these demos, we made small examples where you see these 3 apps I mentioned, and sample management, and patient registry, and some omics data management. Here just 3 screenshots to see the landing page, to see how a sample management would look like, and to see the FAIR data point which is connected to such a solution in our FAIR toolbox. This was a very, very short journey through the FAIR toolbox. The acknowledgement is overall to the HEAP project. We have to do it with these nice numbers and in a formal way, and then in an informal way to the whole team of Work Package 7 who has done the work. Thank you.